It's an incredible honor and pleasure to welcome to Living Histories Satya Majumdar, who's something of a legend from where I come from. And so I am very intrigued to hear how much of the legend will feature in these stories. Please take it away, Satya.
Thank you, Sri, and thank you very much for the invitation. And I should thank you and your teammates and Rudro and other people for putting on together this series of talks, which I find really interesting and original. So today, so just for the people who don't know me, I'm a statistical physicist. I'm working in Paris, in France, for the last 20 years. So I'm a sort of research scientist in what is called CNRS, which is Center for National Scientific Research in France. And I'm actually based in Université de Paris-Saclay, which is one of the 10 universities in Paris. But of course, I was born how do I forward this
Just click on
noise?
the mouse.
Okay, okay. So I was born in India. This is the eastern city of Calcutta, as you see on the map. And and then I grew up in a small town called small town by Indian standards is called Midnapur, which is about 130 kilometers east of Calcutta, west of Calcutta, sorry. So this is where I grew up, and this is my family. So my father was a lawyer, and my mother was a singer and also a homemaker. And I have two sisters. Elder one is Anita, who is a sitarist. She's a musician also, and is also a great cook. And my youngest sister Kakuli, who is a chartered accountant. So, and then I went to school in in what is called the Midnapur Collegiate School. So maybe I can move these things a little bit to the right here. Midnapur Collegiate School. So this is one of the oldest schools in India. It was formed in 1834 during the British India. And there are many celebrated writers and freedom fighters, they all came from this school. So I was very proud to be a student of this school, and I learned many, many things there. And then after my schooling, I came to Calcutta to do my undergraduate and graduate studies. I went to Presidency College, which is on the left, the picture you can see. And this is one of the iconic colleges in Calcutta. I mean, many physicists that who come from Bengal typically go through this college. This was a great time, and because this college produced many Nobel laureates, great physicists, celebrated writers, historians, filmmakers, politicians. I mean, the many of them. I mean, and there are fantastic and really inspiring teachers who taught us, and we learned. This was in some sense the formative years of our life, and I'm still, very indebted to my college for this. And I still have friends from there. And on the right, you see the Calcutta University, Rajabaja Science College, where I did my master's in physics. And So I had really great time in Calcutta those days. And after that, I moved for my PhD. I went to Tata Institute in Bombay. So this is one of the premier institutes in India. And I did my thesis on self-organized criticality, which was a very hot topic at that time on sandpile models. And my PhD advisor was Professor Deepak Dhar, who is on the picture in the middle you see, and also on the right I collaborated a lot with Professor Mustansi Barma, and these two gentlemen were really instrumental in my learning statistical physics, and they were really great people, and I mean I learned a lot from them basically, and without them I could not have been what I am today, whatever little I am today. And so after doing my PhD thesis in 1992, I moved to the US. I went for my first postdoc at AT&T Bell Laboratories, and this was in Murray Hill in New Jersey. And there I changed my topics quite a bit. I worked on more condensed matter subjects like phase ordering dynamics or transport of vortices in high tissue superconductivity, then stress propagation in granular systems. So I worked quite a lot with David Hughes, who is now in Princeton, and also Sue Coppersmith, who is in Australia. And also I shared an office with Clément Cyr, with whom I worked a lot those days. He was also a postdoc like me. also with Anuttam Narayan, who is now in University of California at Santa Cruz. And I also had the great advantage, great opportunity to work with experimentalists in the group of David Bishop and also with Sid Nagel from the University of Chicago. So after my postdoc in Bell Labs, I mean, I got a job offer to go back to Tata Institute as a faculty, but I decided to actually stay for a couple of years more in US to work on quantum systems on which I had never worked before, and I had the great opportunity to go work at Yale University for my second postdoc. And my advisor was Subir Sachdev and Rammurthy Shankar. And there I worked on, cold atoms, disordered quantum spin chains, quantum phase transitions. And also at the same time, I started a very long-standing collaboration with Professor Alan Bray from the University of Manchester on persistence and first passage properties in out of equilibrium systems. Also, I had the opportunity to work with two great graduate students of Subir, Senthil, who is now in MIT, and Kedar, who is at Tata Institute, and also with Anirban Sengupta, who is now at Rutgers. So after my second postdoc, then I actually went back to Tata Institute. I want to go back to India always as a faculty in TIFR. And there, I was there for 3 years, and I worked with three very important graduate students, Supriya Krishnamurthy, Abhishek Dhar, and Rajesh. Now, I wanted to stay in India, but in between, I met my wife, Victoria. She's French. And this is the reason I actually moved from India to France. And this is a very recent picture. We were in Kerala for the Christmas, just before the New Year's Eve. And so I joined finally CNRS in 2000 and I moved to France. And so first I was for 3 years, I was in the University of Paul Sabatier in Toulouse, which is in the south of France. And there I worked quite a lot with David Dean, who is a long-term collaborator and a very close friend of mine. And but then my wife was based in Paris. She didn't want to move to Toulouse, so I had to come back to Paris. So I moved to Paris to Orsay actually, and in a laboratory called Laboratoire de Physique Théorique (LPTMS), Laboratoire de Physique Théorique and Model Statistics, in 2004. And I've been there since then for the last 20 years. So this is the picture of our lab when it was snowing. And so this is a great lab. And, I mean, the greatest thing of this lab is that, in Paris is that we really get fantastic, fantastic graduate students and postdocs. And so these are all my students. I cannot now name each of them. I mean, there are a lot of them, and also a lot of postdocs. I mean, they're all really, really great. It was so much fun to work with the younger people, and I also learned a lot from them. And some of them are still doing their PhDs. Like this is Marco Biroli, and this is Ivan Buranev, and this is Mathis Kuhner, etc. So also there are faculty people at LPTMS who were really great. There's a black band somewhere. Okay, so Oriol Bohigas and Comte and many other people here. Some of them are still there, and I had great opportunity to collaborate and work with them. And apart from them, I also had, many other collaborators across the world, outside France and everywhere, anywhere else. And it was, I mean, I'm really, very, very grateful to all of them because I learned a lot from them. And I think, in one of the great things about working in science is that you get to collaborate with many, many people from many different nationalities. And it's always a great fun and, great learning procedure. And so, just a brief slide about the kind of subjects, about research areas I worked on many many different areas. I will not go through all of them in details, but basically on the right you see essentially I work in statistical physics. Although the problems I work are often inspired by computer science or biology or statistics or probability theory, and they range from from experiments in high TC superconductors to random matrix theory to granular medium and many many other things. So this is the great thing about statistical physics is because it's very broad. You can actually learn and apply the techniques to many many different areas, and that's always a pleasure. And so here are just my last slide, just a few reflections for the younger people. So first is that the most important thing I think, no matter what you are doing, Well, academics definitely, since all of us are doing academics, that enjoy what you are doing. If you're not enjoying it, no point in doing it. And the second thing is that, we often talk about big picture, which is nice, but one has to pay attention to details because the real understanding is in details and real scientific understanding. And also you have to choose your notations well. I mean, so that it's accessible to, younger people and other people, everybody, so that people actually read your papers. I mean, choosing notation is very, very important. Then it's very important to be very, open and broad. I think the main point is that these similar questions arise in very different fields. So you should be open and, it may look very difficult under the sort of, guise of jargons and so on. But once you go over them, I mean, basic questions are same in all fields, I think. And so it's very, important to be broad, and you should talk to your friends, collaborators, students, attend seminars, and knowledge spreads via diffusion. So it's very, very important to be open and broad. And also, it's important to work and share ideas with others because that's real fun. Because otherwise, if you work on your own, it's nice. I mean, you can get good ideas and you feel glory to yourself, but it's not so much fun as to when you share your ideas with other people. I mean, that's really at least somebody. If other people are not reading your papers, at least somebody can see exactly what you are doing. So that's really great fun. So that's it. So most important is that ask good questions and have fun and enjoy whatever you are doing. So that's all. I hope I've not exceeded my time straight.
No, not by a lot. Thank you so much, Satya. That was a wonderfully inspiring talk. On behalf of the audience, I'm thanking you. There's a bunch of questions that have come in, and I'll try to ask a selection.
Yeah.
How do you choose your next problem to address?
How do I choose my next problem? Actually, this is a question that often the students come to ask you that what is the project I'm going to work on. I mean, to be honest, I mean, as a theoretical physicist, I will say, we never know what is the future project. I mean, you work on different things, you come across interesting questions, and then, something leads to the other things. I mean, it's not like that this is the problem I have when I have to write my grants. I cannot really say what I'm going to do in 5 years time. I do what I enjoy. And so selecting a problem, I would say, when you read or when you hear a talk, seminar, and you think of some interesting question to ask, and that leads to something. At least it has worked with me like that always. I mean, I never really pre-decide which area I'm going to work on.
I
So,
feel like the next question asks itself, which is, given what you are saying, which sounds like a lot of fun, which is being guided by serendipity and interactions to figure out what you want to do next, how do you not, let me ask it positively, how do you navigate a system that requires you to think 5 years in advance?
ah, well, I mean, okay, I can just give you an example. I mean, again, I don't have a good answer to this question, but for example, in 2006, I was in Cambridge and for a conference, and I just got bored with the talk, and I just was wandering around, and I went to a seminar by a string theorist. I didn't know anything about string theory, but this guy was talking, and from his talk, he was asking about the number of stationary points of a random landscape in the landscape-based string theory, and so then you just think, okay, and he was talking about trying to find the answer using random matrix theory, and I didn't know anything about random matrix theory neither. So I started thinking about random matrix theory, and then one thing led to the another. Before that, I didn't know. I knew the jargons, but I didn't know the subject. But then you start digging into it, and you discover it's a beautiful subject with many many applications, and that sort of laid this sort of stepping stone for my next 10 years of my research from 2006 to 2017 or something like that. But honestly, I didn't really think in advance. So navigation. Yes, navigation is important, but once you are in the subject, you have to, get to the core of the subject, and then problems automatically arise. Interesting questions automatically arise, and you address them. That's it.
Thank you, Satya. There are many, many more questions in
Oh,
chat.
sure.
Ask. I'll ask the people who are asking them to directly send them to you in the interest of time.
Sure.
Uh,
Perfect.
and I'm closing the recording after thanking you
Okay.
one more time.